As a way of showing the advantages I've found using dictionary attributes and loops, we'll create a table with headers, which will become attribute names, with rows of attribute values underneath each of the headers, and import that into Houdini. And you can see here that for each one of the rows, it's brought in values and applied them per point. And each one of those attribute values is under their attribute name or header. And then we'll loop over each one of those points or rows. And for each one of them, we'll create some geometry based on values from each one of those rows. And in this case, we calculate percentage. And you can see here that I'm making a slice per row based on their percentage of value. Now, normally you would create the geometry for each one of these slices and differentiate them by putting expressions in, perhaps, and reading back to each point's data. And those expressions can get really long, or you can make them short by reading, just saying detail expression back and doing all your calculations outside of the loop or in the loop in a wrangle and reading from one place. But you still have to put a lot of expressions in each one of the node's parameters if you have many parameters to change. And I found it a lot easier to, in one detail wrangle, use something called dictionary attributes and write out the parameters from this detail attribute. And the only thing I have to set in each node is do a spare input and an override. And that way in one location, I can manage all of the operators inside of my loop as long as the parameters don't share the same name. In which case, I just need to make another detail wrangle. One place we can create a table is inside of Google Sheets. You can create it in Excel or wherever. All I did was hand input header with values per header in each row underneath. And then in our case, we're going to use a CSV file, comma separated values file, and or you can just hand make that by putting some headers, and each column is separated by by commas, and then each row is separated by a return. For those of you who are just going to make your table and use it in Houdini, you can just skip this part. I'm just going to show setting up a table in Touch Designer. The reason being that maybe you want to collect data and manipulate data in Touch Designer, collect it in real time, and then shoot off better looking renders in Houdini. So to set our project up, what I usually do is combine the Houdini and Touch Designer projects. So as usual, I'm going to say new project and stick this somewhere. And let me see here. There's a good spot. There we go. And just say accept. And I'll call this project Pi. And Houdini has sort of this double naming thing, which kind of drives me nuts, which is like project. So we'll just call it Pi and say accept. And then while I'm here, I'm going to add a folder called DAT, because later on we're going to use Houdini DAT nodes. So I'll say accept. And then you can see here, if I go to that folder, it's made a project called Pi, and there's all the folders and the new DAT one. So we'll go to Touch Designer and do the same thing. We'll go File, and I always forget where the hell that is. Where is it? File, Create Project Folder, and we'll say the project folder is going to be the one that we just made, which is called Pi, and select it. And then we don't want it to name anything here, so I should have just left it as F. That's fine. So same as before, F and Pi, and it's going to make all of these folders and say create. And you can see here that it added those additional Touch Designer folders. So now that we have our folders set up for Houdini and Touch Designer to share in one place, I will do a file save to that new location, And I'll just call this file pi, and it'll resave everything and say accept. And then in Touch Designer, when you create projects, it's not really necessary. It automatically does that. So now they're going to be both in the same location here, the toe and the hip file. So Touch Designer should look really familiar to those of you who don't know it that are coming from Houdini. Back in the days when Greg and Kim were working together, a lot of this came out of Chops, and they're both just fantastic applications and very compatible. So I'm going to hit Shift Select here and just delete those nodes, and just like Houdini, I can hit Tab and add some nodes. In this case, I'm going to just copy paste from another Touch Designer so we can save some time. I'll save this file for you guys so you can just copy paste as well. So I want to run this in Houdini, and so I'll just copy this. And what this is going to do is set up a server so that we can speak to it from Touch Designer. So I'll get a Python shell and just put that in here, hit enter, and now that server's running so we can talk to it from Touch Designer. So going back to Touch Designer, a couple of things we need to do to set it up is we need to set up our Python. So I'll paste this in here, and again, I'm going to save this file out from you guys. We need to run this inside of Touch Designer, so I'll just split screen this, change this screen to a text port so we can see the Python running if we need to for any reason. And I'll close this window so we have more space here. All right, so let's just take this and run it. So right click and run script. Perfect, no errors. And then I'm going to need a table to read from and to write out to Houdini. And there's lots of ways to make tables. So let's just go tab and make a box, I guess, and go to Sops. Where's box here? There's box. I'm going to take this box and, you know, just like Houdini, you know, it's 3D, it's made up of points, and those have attributes. So if I were to go to, and let's go SOP2, and what's SOP? This is going to from SOPs to DATs, and so just like in Houdini, I can drag and drop here, and I'll put that in, and that's automatically made a table for us so that we could then import into Houdini. Instead, I just hand typed one just like I did in Google Sheets, so we'll just use that for now. It's easier to work with for now, so I'll just paste that here. And all I did was went and went and got a text dat. So let me just put one down here and hit the plus sign so I can edit. Oops, not text, I did table. Sorry guys. So let's get rid of that and tab table. And there's a table dat, cool. And if you right click on the rows and columns, you can click here and say add after, it's going to add another column, and then over here add below, it's going to add another row, and then you can type in your items and your headers, etc. So I'll just delete that, we don't need that table. We'll use this table, it's called table 1, which is going to be important in a second. And I wrote a little script here, and I'll explain it when I copy it over, and we'll stick it right here. All right, so what this script does is it connects with the server that we just set up in Houdini, and then it gets the path name of the HIP file that we're connecting to, and then it's going to use that in a second to write a path for the table that it's saving out here. And that's the advantage of having the same project, is everything is nicely connected. And then it's going to set parameter values in that table. So before we do that, you'll see here that I am writing out to something called stage pi sopnet create. And we don't have that set up in Houdini yet. So I'm going to go over to Houdini, and in our stage here, I'm just going to do a sop create like this. And I'm going to call it pi. and our table will show up in here when we run the script. So I'll go back to Touch Designer and move this over and right click on this and say run script, and go back to Houdini, and there is now a table node in there, and you can see that it's brought in everything and has set up the headers as attributes per point, and the values per row have also shown up. All right, so I know that I want to take this data and make a pie chart, which is essentially a circle or slices of a circle. So let's get a circle node here, and we'll open ArcIt and take a look at it here, and let's just make it a little bigger. And you guys probably can't see it that easily, so I will just set the wire width something a lot higher so you guys can see that, and make the background dark. There we go. All right, so I got my open arc and my beginning and end angles that you can already start to see would be a good slice, and then I got my divisions here, which I'm also going to want to drive, and that's about it for our pie chart. So I could write an expression and put an expression in each one of these parameters. But again, I don't want to. That's too much work. So instead what I'm going to do is do add spare input and add parameter override and get a detail wrangle. And take the detail wrangle here and go back to the circle and just drag the detail wrangle into there, and then set the parameter override to that spare input. And let's take it circle. I look at circle at some of the parameters we can drive. So if I hover my mouse over, I can see the parameter name is scale, lowercase here. So let's do that. So let's go D at parms, and the string name there was just scale. And we'll set it to something we can see the difference on, 0.5. And that's it. Now you can see that it got smaller. So I also know that we need to change the beginning and end for our slices. So if we go and look at circle here, you can see I have arc angles, and I have begin angle and end angle. So let's try it. Let's go and say D at parms, and let's do begin angle. And we'll say the begin angle will be like, I don't know, 50. And see what happens. And nothing happens. And it looks like it's spelled right, begin angle. And I go over here and look at it, and yep, begin angle. But nothing's happening. So the way to find the correct parameter names to drive is, I found there's lots of ways you can do it. There's a node, attributes and parameters or something like that. But you can also, I found, just use recipes and go save node preset. And you'll see down here arc angles is actually just one parameter name called angle with two items. So what we'll do is go back here and say it's just angle, and say angle, and then we'll set that. So we'll say set, and what we'll do is we'll set 50 for the beginning angle, and then maybe, I don't know, 100 for the end angle. And now you can see here that I am indeed able to change it via the detail wrangle, which is going to be quite handy when we take the table values and loop through them and want to adjust each of the slice beginning and end angle relative to the data that's coming in. Let's make use of the table with our detail wrangle and dictionary attributes. So add a attribute promote node, and we're going to use this just to add up all our amount values. So I'll call the node sum so we know what it's doing, and we're going to sum this, and we're going to change the new name to sum. and we don't need to delete the point attribute. So the attribute that we want to get is the amount, because that's what we're going to sum. So we're going to take all these amount values and sum them, and then we're going to write that out to detail. So if I take a look at this node here and look underneath the detail attribute, you can see the total is 126 if you were to add all of these, add all these up. And what I want to do that is turn that into a percentage. So what we'll do is we'll get a point wrangle here, and we'll go through all the points and divide it by the sum, the amount. So I'll just copy the code over to save you guys some time, and I'll explain it. So take that, and what I'm doing is I'm saying this new attribute called percentage is going to be equal to the amount of each point divided by the total of all the points, and that gives us a percentage 0 to 1, which is what we need for a circle, 0 to 1 to create a pie chart. And then what we're going to do is we're going to take our detail wrangle here, and same as before, we're going to write out to the parameters. And so what I'm going to do here is I'm just going to say that the n angle is going to be equal to the point size, which in this case is percentage this time. Percentage, sorry guys, percentage. And then we multiply it by 360 because that's how the circle node is expecting it, is in degrees, not 0 to 1. So we get the angle by reading the percentage for each point, right? So we're looking at the first input, 0, and then each point, and in this case we're just going to get 0.0. And the way we want to do is we want to set that on the circle to be the start angle. So let's just put that in here and say the angle is equal to 0 to the n angle. And we'll get another circle node here and stick that over here and add a spare input and add an override and drag and drop this detail wrangle in there and set the override to spare input 0. And now, if you look at that, you're not going to see anything changing until I change it to open arc. And now you can see that you can't see the values in here, unfortunately, when you're driving them, but they are being set to 0 times whatever the, 2, whatever the end angle amount is. Just to show that this is actually changing, let's change this name so we know what it is later. We'll call this percentage, and then after our table here we'll just do an attribute adjust float. Where is that? There we go. And the attribute that we want to adjust is going to be, let's grab the first point, and the attribute that we want is going to be, we know it's amount. So let's grab amount, and let's just set that rather than changing it. So we'll just say we'll just set always, and then what we're going to do is keyframe this. So let's maybe on the first frame set this to something kind of small here, and so I'll just hit Alt, click, and I now have a keyframe, and go to the last frame here, and Alt keyframe, and you can see that this now animates, and down here this is now driving that parameter. So the next thing I want to do is put this in a loop to create each of the slices for our pie chart. But before I do that, I need to do more than just get a sum. I need to get a cumulative sum. And the reason is I need to be able to get what degree the beginning is and then the next one. And then I need that value to start the next one. So it doesn't always keep going back to 0. So it's a cumulative sum. So what we'll do is we'll add a detail wrangle. And I'm going to call this cumulative sum. I guess that makes some people laugh. And I'll just copy the code over and explain it to save you guys some time. And it's not size anymore. This is going to be percentage. That's just an attribute name I was using before. And so now I have the cumulative sum for each one of the four slices to build on to go to the next point. And I'm doing that outside of the loop because that will save some overhead. And then I'm also going to add a color node here just to get some differentiation of each of the slices. So what we'll do here is just do a random color. And so maybe change the seed, I don't know. We'll play with it in a minute once we put this in a loop. And then I'm going to do a for each point loop and add that here. And then what we're going to do is we're going to do a copy to points, and we're going to copy our circle to each of these points. So we'll take this, we're going to copy to points, and oops, we don't need it directly from the detail wrangle. We can just leave the detail wrangle off to the side here, and then we're going to be copying the circle to each of those points. And right now you won't see any difference. It's treating everything kind of the same. And so what we're going to do is we're going to add the detail wrangle as part of the loop here. And it's still not adding up correctly, and that's because we have to change some of our calculations in our detail wrangle. So in our detail wrangle, I'll just again copy paste some of the code over to explain it to you what it's doing. And so I need to change size again back to percentage. Again, just an attribute name I was using previously. So it's kind of hard to tell that each of these is doing something different. I could try changing the seed in the color to see that it is actually doing slices, but it's probably just better to add a point in the middle here. So I'll just do an add point here. And what I did before is I just said, I added a single point, and then I said, made a polygon by group, and I said all points, and then I closed it. And so now I have a slice for each of the circles here. And if you slide it here, you can see it's animated, and I have all four slices. So let's go back and look at what the code's doing. Basically, it's saying for each point that's coming in, you're going to make a circle, and but it's a slice of a circle with a start and an end. And the start is going to be the cumulative sum times the 360 for degrees, and then the end is going to be the cumulative sum plus the percentage. So each time it comes in, you're getting its total percentage plus where the previous end angle was from the previous slice, which is cumulative sum, which we were calculating here, so that this slice goes from here to here, and the next slice starts at the cumulative sum and then goes to its full percentage plus the cumulative sum and adds it up. And then we just used an add node to put a point in the center so that it could draw a polygon. So a couple other things to do to finish the pie chart. Let's just move this down to make some room. And we'll do a poly extrude and stick that here. And let's increase the distance by a bit. And doesn't really matter what it is, but I do need to set a few things in here. Let's put the front group out and the side group out here, and then what we're going to do is actually blast those. So I'll just get a blast node here, and it'll make sense in a second. So let's get the blast node here, and we'll get those two groups that I added, and we're going to say delete non-selected so we get rid of the original lines that we're using to extrude from. And then what we're going to do is do a little poly bevel. So poly bevel here, poly bevel, there it is right at the top. So we'll do a poly bevel, and yeah, I did use a group for that. So we'll do a poly bevel, and the group that I used was extrude front. So we're only beveling that, and then we'll just bevel that a bit, and then give this some divisions just around it. I'll turn off points. That's getting pretty distracting, but actually that's definitely too far a distance to be beveling. But while we're here, you can see that the points are bunching up because I have the same number of points per slice. So again, nice thing here, we can just control that in one location with our detail wrangle. And I'll just again grab the code and bring that over here. And we're going to base it on the start and end angle, and then divide it by something. So I'll just stick that here and say that divs is equal to that. And now you can see that because we're driving the divisions on the circle, that it's relative to the length. So I'll turn on points and put this back to smooth shaded so you can take a look at the tiny little bevel that we have on there. And now we have a smoother, more consistent surface because the points are distributed evenly. All right, so let's add some text to define some of our slices here. And so I'll add a font into our loop here, and do a copy to points. Copy to points. And the point we're going to want to copy to is something we're going to extract from our circle here. So what we'll do is we will use a carve, and we're just going to carve the edge of our slices here. And we'll do this so it's clear what we're getting here. And we'll do 0.5. And so now I have here, if you look up close, it's hard to see here, so to make my text bigger. Still too hard. But 0.0 is the top one. And if I hide that here, you can see that I'm getting the midpoint, which is 0.0. So I take that, and then I take a blast, and I blast 0.0, just to make sure it's points here. And we're going to delete non-selected. And so now I'm just left with that midpoint, which is great. And so we're going to copy the font to that. And then what we're going to do is we're going to take this and put it into a merge node so we can see our fonts for each slice alongside our circles here. And so let's stick that in a loop. And wow, it's really gigantic. So let's take our font node here and make that a lot smaller. And turn off point numbers. So our text is embedded inside. So we'll get a transform node. And since we're doing a circle, we know we can scale out from 0. So I'll take the transform node and move each one of these points away from the center. So I'll just take transform here and stick that in there. And I know I can just scale it out, and that's going to move each of the fonts away from the pie. Pie is probably a little too deep here, so let's just change poly extrude and lower that a bit. Okay, now, they don't really say anything, and they should. So if we look back here at what's available to us in terms of attributes, we know that we have a name attribute that we're not using. So same thing, let's go to our font and let's do an add spare input. Let's add a parameter override, drag and drop our detail wrangle in there, and set the spare input to that. And then what we're going to do is on our detail wrangle, we will write to that text parameter. So what I'm going to do is we're going to get, I'll just copy the code over here and explain it. What we're going to do is get that point attribute value for each point coming through. It's the first thing coming into the wrangle, and then it's 0.0. It's always 0.0 because we're always looping on only one point. And we're looking for the name value, and then we're going to set that to the name. So now you can see here that if I go back to all the points coming in, there's the names for 0.1, 2, 3, 4. And if we go and look at it in a loop here, you can see that that it's outputting those different names per slice. Now, there's an issue here as it's animating, and we'll work on that in a second, but I want to make it clear which which slice these are associated with when they get too close together. So what we'll do is we'll add a line node here. And so what I'm going to do here is just get another merge. So these are merged together. And I want to draw a line between two things. I want to draw a line between the mid node, the midpoint here, and the I'll show it to you where we scaled it out. So I want to draw a line between the edge of the pie slice and the font. And then what we're going to do is we're going to say add to add that line. And so we'll go like this. We'll just say, oops, wrong thing. Sorry, guys. We'll add. There we go. Like that. And then polygons are just going to be, we know there's only 2 points, so it's 0 to 1. And we go and look at our add here. And we now have a line. And then for rendering later, we're going to want to set a width attribute so that we can see it and make adjustments as we're rendering. So let's just say width equals, I don't know, 0.1 for now. I'm not sure what I set it to before when I was experimenting. I set it to 0.02. I guess it was really huge. So yeah, 0.2, cool. And good practice, we may as well name it too while we're here. So with a primitive wrangle, I'm going to do this and just say @name equals line. And that way we can differentiate it when we're working with materials later. And then we're going to take that and stick that in our overall merge here and have a look at what that looks like in the loop. So now you can see that the line is going to the text, but it's hitting it in the center, and that's not really good. So a couple of things, if you look under the font here, you can see that one of the other parameters we can do is do our horizontal alignment. So let's adjust that as well. So what I can do, and I'll just have a look at what I did before with the detail wrangle, is we want to get the start and the end angle to find out where that is. And the reason is here is if I just say alignment and say left, these ones look good, but this one's not looking good. So I want to say, I want you to align left when you're on this side and right when you're on that side, so that it's working. So I have to set a condition for that. So let me just copy it over and I'll explain it. Okay, so what this is doing is that it's getting the start and the end angle minus the start angle, and it's figuring out what side, you know, if there's 360 degrees, if you're on this side of 180 or that side of 180, and that's saying whether you're going to be left or right, which is either 0 or 2. If you go and look at the font here, there's numbers associated with each of these choices. And this is what we're overriding with this detail wrangle. So now, as you animate that, you'll see that the text will actually flip its alignment depending on what side of the circle it's on. All right, so I cleaned house a little bit and added some name nodes, which we'll use for materials. So I just said text is text, lines are lines, slices are slices. So we'll go up a level here, and yeah, we can leave on Carmax view, and we will add a new camera to that, and then add a Karma nodes to render that, and then we'll lower it so we can get some speed out of this to something smaller. Not that this will take a long time, but could have it, may as well do it. And then we're going to do material library, and we could do linking or whatever, but this is fine. So, and inside of it, we're going to do a material X builder, and we'll call this one slice. And inside of that, we're going to make sure, even though it does it by default on some things, we're going to use the geometry color that we're getting, that we assign to inside of the Sops, and we're going to say that's the base color here. And so it's not applying it yet, so we'll do autofill materials, and we get slice, and we'll say assign a geometry, and we'll drag and drop slice over to the path, and now we know that the slices are getting that material. So we'll go back in there and we'll do another one for the lines, so Control CV, and we'll call this one lines. And head up a level so we know it's being applied. And same thing, put lines in the path here, and then go in there, and let's differentiate this. So let's maybe take the geometry color and change it. Maybe we should look at it lit first. So what kind of a light here? Let's do a distant light. So we'll just take a distant light here, stick it in there, and that looks pretty awful. I don't know. That's okay. And maybe crank out up a bit. Sure. Okay. And just save that. Go into our material library here, and let's click on our lines, and maybe we want to adjust those lines a bit here. So let's do some kind of an adjust and stick that in there, and then the amount we're going to adjust it by is going to shoot it over the color. So let's just do a little bit, because we want it just like a shade off slightly, so it's similar. Cool. All right.